This lecture contain or option question number 2C. Or option question number 2C. Define nth term test for the divergence of a series. Test the convergence for the following series. First series, summation n is 1 to infinity 1 upon n square root of n. Second series, summation n is 1 to infinity n sine 1 upon n. Now in this question, first of all, here we are defining nth term test for divergence of a series. For this, we need to discuss necessary condition for the convergence of an infinite series. Okay. So first of all, what is this condition? If the infinite series an converges, then its nth term must satisfy limit n tends to infinity an equal to 0. Okay, so this is the necessary condition for convergence of an infinite series. If series an is convergent series, then its nth term must satisfy this condition. Limit n tends to infinity an equal to 0. Okay. Here what is the an? An is nth number of term. Okay. मतलब कि अगर सीरीज कन्वर्जेंट है तो लिमिट n टेंस टू इंफिनिटी an इक्वल टू 0 होगा ही. सही है. तो अगर लिमिट n टेंस टू इंफिनिटी इज नॉट इक्वल टू 0, व्हाट डज इट मीन? कि ये सीरीज क्या है? कन्वर्जेंट नहीं है. ओके, कन्वर्जेंट नहीं है मतलब क्या है? कि ये सीरीज क्या है? डाइवर्जेंट है. सो nth term test for divergence is nothing but the necessary condition for the convergence, but this one is written in other way. Okay, so if limit n tends to infinity an is not equal to 0 or does not exist, then the series an is divergent series. Got it? मतलब कि necessary condition हमें क्या बोल रही है कि if series an converges, then limit n tends to infinity equal to 0. ओके, ये कंडीशन सेटिस्फाई होगी. मतलब कि अगर लिमिट n टेंस टू इंफिनिटी an इज नॉट इक्वल टू 0, तो इसका मतलब क्या है? कि ये सीरीज क्या है? कन्वर्जेंट नहीं है. कन्वर्जेंट नहीं है मतलब क्या है? कि ये सीरीज क्या हो जाएगी? डाइवर्जेंट. ओके, सो nth टर्म टेस्ट फॉर डाइवर्जेंस इज नथिंग बट द नेसेसरी कंडीशन फॉर द कन्वर्जेंस. ओके, सो you can define in this way. Define nth term for the divergence. Now discuss the example. First question, summation n is 1 to infinity 1 upon n square root of n. So now here n square root of n is nothing but 1 by 2. So here n raised to 1. Okay, so here base is same, so we can add the power. So n raised to 1 plus 1 by 2. So this one is nothing but what? N raised to 3 by 2. Okay. So here what we get? 1 upon n raised to 3 by 2. Now compare this with the P series. So what is the form of P series? Series 1 upon n raised to P. Okay. And for P series, when we say that the given series is convergent, if P is greater than 1, then the series is what? Convergent series. Okay, तो यहाँ पे what we get? P equal to 3 by 2 and 3 by 2 is greater than 1. So since a P series converges for P greater than 1, the given series converges. Okay, so that's why the given series 1 upon n root n is convergent series. Or option question number 2C, second question. The series is n sine 1 upon n. Now here we are interested to find the convergence of this series. Okay. Now for this, what we use? We use nth term test for divergence. तो ये टेस्ट अभी हमने प्रीवियसली अभी डिस्कस किया, बराबर है. सो व्हाट इज द nth टर्म टेस्ट फॉर डाइवर्जेंस? इफ लिमिट n tends to infinity an, and an is what? Nth number of term, okay, is not equal to 0, then what we conclude? The given series an diverges, okay. Now use this test to find the convergence of this series. So now first of all, as per this definition, take limit n tends to infinity an. So what is an? An is equal to n sine 1 upon n. Okay, so now limit n tends to infinity as it is, n shift in denominator, so it become 1 upon n. So next term is what? Limit n tends to infinity sine 1 upon n upon 1 upon n. Okay. Now next, take the assumption, put x equal to this 1 upon n. Okay. So now x equal to 1 upon n. So also we need to change the limit. Now x is what? 1 upon n. And here what is given? N tends to infinity. So as n tends to infinity, x tends to what? Here 1 upon infinity. So x tends to 0. Okay. So now put the value of x in this. So what we get? Limit n tends to infinity n sine 1 upon n is equal to limit here n tends to infinity means what we get? X tends to 0. And here sine 1 upon n is replaced by x. So we get sine x upon cos x. Okay. So we have this value. Now use the standard limit. This result we already know. Limit x tends to 0, sine x upon x equal to 1. Okay. And this limit is true for cos function also. Okay. So now put this value, limit x tends to 0, sine x upon x equal to 1. So put here. So what is the value? Here we get value 1 from this property. Okay. So we get limit n tends to infinity an is equal to 1. Okay. 1 means not equal to 0. Okay. So from this result, what we conclude? Limit n tends to infinity an is not equal to 0 means series an is divergent series. Okay. So that's why here what we conclude? Series n sine 1 upon n is divergent by the nth term test for divergence.